Okay, this video is on enlargement, area and volume, and this is all about if you maybe have a scale factor, so lengths might be doubled, what happens to the area and the volume. And some of you might think it just doubles too, but no, this is the key point of this video. So first of all, we're going to look at if you just had a scale factor. So I have two similar shapes here. So I've got a smaller one and a bigger one, and it's a 3D shape. And I'm saying the scale factor is n. So for a side, to get to this side, I would multiply by n. So that is any length I have on this drawing, I multiply by n. So if this is length 10 centimetres, the length over here is going to be 10n centimetres. So to scale the sides up, I just multiply by the scale factor n. However, this is where it gets a bit different. So when you're talking about surface area or volume of these shapes, you can't just multiply by the scale factor. That's only for lengths of sides and things like that. So the area, instead of multiplying by just n, you have to multiply by n squared. So you have to do the scale factor squared. And it's kind of easy to remember because area, our unit's always squared, you know. And volume, then, you can see the pattern, is going to be n cubed. So, for example, let's say I have these two 3D shapes here, and these are similar shapes, mathematically similar, and I say it has a scale factor of 2. If I said that this side was length 8 metres, what is the side of x? Well, I know it's a side, so I know the scale factor is still just 2, so I know that this is going to be 8 multiplied by 2, so 16 metres. However, if I told you the surface area of this shape was 40 centimetres squared, what would be the surface area, so I'm going to call it SA, South Africa, what would be the surface area of the larger shape? And I can't just multiply it by the scale factor now, I have to multiply it by the scale factor squared, so 2 squared, which is 4. So my new scale factor is 4. So I would take 40 and I would multiply it by 4, which gives me 160 centimetres squared. What if I said the volume of this shape was 800 centimetres cubed? What is the volume of this shape? So now I know the scale factor isn't just the scale factor of 2, the scale factor for volume is 2 cubed, which is 8. But this time I'm going from big to small, so I'm going to do 800 divided by 8, which gives me 100. So this would be 100 centimetres cubed. So basically, if you're looking at area or volume, you have to just do one more step with the scale factor to work out your area scale factor or your volume scale factor. If we're trying to work out n in the first place, the scale factor, how do we actually calculate n, the scale factor? So n is the new length divided by the old length. So that is the scale factor for the sides, or what we normally have previously seen as the scale factor. If I'm looking for the scale factor for area, so n squared, that is going to be so the difference here, instead of new length over old length, n squared is going to be new area over old area. And then volume, n cubed is going to be new volume over old volume. So we'll see this in 2 exam questions now. So first thing you have to do is work out the scale factor and then kind of make the calculation you need. Okay, so first exam question, apologies for the drawings. So A, B are mathematically similar, so they're going to tell you that because that's really important, otherwise you can't really do this enlargement thing. B is twice the size of A. The surface area of A is 180 centimetres squared. What's B's surface area? So you know they're mathematically similar, so they're kind of related in some way. So it's actually giving you the scale factor in the question because it doesn't have any lengths or anything. So it's saying B is twice the size of A. So we know to get from A to B, you multiply by 2, so that would be length. So the scale factor is 2. So that is n. n is equal to 2. The surface area of A is 180 centimetres squared. What's the surface area for B? So the trick is here, we're actually talking about area. So what is the area scale factor? Because that is different to the lengths. And we know that the area scale factor is n squared, and we know n is 2, so it's 2 squared, 2 multiplied by 2, so that is 4. So therefore we know that the smaller shape has a surface area of 180, and we want to multiply by the scale factor, but the area scale factor because we're dealing with area. So we're going to multiply it by 4 to get B's surface area, and that is 720 centimetres squared for the surface area of B. So the only trick here is, first step, finding out the scale factor, and then 2, finding the actual scale factor you want to use, so the area scale factor. So let's do another one. So this is your next question, so a bit wordy. It's always nice when you have a little diagram, but you know, we'll work with it. So we have X and Y are two geometrically similar solid shapes. So that's a bit of illustration there. Similar means the same shape but different sizes. Surface area of shape X is 450 centimetres squared, and the surface area of Y is 800 centimetres squared. The volume of X is 1,350 centimetres cubed. What's the volume of Y? So we're looking for the volume of Y. So we need the volume scale factor. So we're looking for the volume scale factor, but we're going to have to use the information that we've been given. So all we know right now is the surface area of X is that, and the surface area of Y is blah. So we can work out the area scale factor. And we know the area scale factor is n squared. And that is equal to the new area divided by old area. So the new area, so the area of Y, the new shape we're trying to find, over the old area, which is 450. And that cancels down to 16 divided by 9. So we know that n squared, so n squared is 16 over 9. So why don't we just try and find the basic scale factor, so n. So we know that n squared is that, and we just want n, so if we square root this side, we get 16 over 9 rooted, and that is going to be 4 divided by 3. So we know n. What we're looking for though, we're looking for the volume scale factor, so we want volume scale factor, which we know as n cubed, so we want n, which we've just worked out, cubed. And that is 64 divided by 27. So now we found the key bit we need, we just need to substitute in some numbers and find the answer. So we already know the volume of X is 1,350, and we're going to use the scale factor, the n cubed, the volume scale factor that we've just found to find the new one. So multiply it by our factor we found, and that is going to give us the volume of Y. And that gives us an answer of 3,200, don't forget your units, centimetres cubed. So I hope that's shown you the fact you have different scale factors for if you're just looking at the lengths, area or volume, and that is n squared, n cubed respectively, and also how to work out the scale factors, but if they're giving you area, be careful that is n squared, or volume would be n cubed. So that is everything you need to know on enlargement, area and volume, and just that is more for higher tier papers.